Hello, good morning everybody. My name is Rob, I'm that developer dad, and I did some tweaking of my physical space here yesterday, and I'm just getting used to new camera angles, and I figured out how to blur my background so that you don't have to look at my messy workspace or anything like that anymore. Yesterday we did quite a bit of project planning. Um, we managed to hash out some requirements and get those put together. And this morning we are going to dive into looking much more closely at those requirements and trying to determine which ones are likely to be volatile over time or widely applicable. So let's open up. Well, let's share the screen first. Here we go. All right. I've got the GitHub project open. Let's go into this. We'll mark it as in progress just to keep track. And each requirement can be further analyzed to determine whether the desired capability will be reused or shared throughout our project, or if it will likely change often as new requirements are added, altered, or clarified. We should ensure that each requirement is true for only one of those vectors of volatility. And by identifying areas of change, we'll be better able to make intelligent decisions about what code goes where in our solution. All right, so now we're starting to bridge the gap between more business and technical analysis of what we want to do and the architecture for the resulting solution. So let's open up the Finder, go to our code folder. Let's open this guy in Visual Studio Code. Very good. And I think I want to go with, let's close that panel. And we'll pop that open. And let's actually go directly to the repository. And go into the docs folder, the requirements. Here we go. We've got our feature wish list, functional requirements. I think we put the details for the townsfolk generator in here. So functional requirements, we've got all these. Technical requirements, all right. NPC generation process, we got to gather basic information, derive the things that we can derive from species and profession, generate game stats, generate personality from profession, species, and stats. We have a data type, game character. We've identified a resource and an engine, rule sets and dice bags, very good. We're not going to account for AI augmentation during our initial design. That's important to remember. But we want to keep our design open for extension so that we can add that AI augmentation if we decide to go there without having to modify our main townsfolk generator application too much. Like, the only reason we should have to modify the townsfolk generator when we add AI is to have it make the call to the AI component. We don't want to have to alter the design or the data or the algorithms that we create or anything like that. We're going to have to modify them a little bit, but we don't want to really have to change the entire stack of the application when or if we decide to bring in an AI component to the to the solution. So we've defined what our rule sets and the dice bags. Why are we calling it an engine? Okay. Let's come up here and take a look at our functional requirements. And let's just hide that over here. And let's split our screen. And there's probably a fancy way to do this, just with keystroke combinations, but try and teach an old guy new tricks, and you're gonna get a confused old guy. And let's pull this like so. What's this? I can close that window. Goodbye. No, I don't want to save those changes. That was just me testing to make sure I could actually see the text with my laptop farther away from me than it was yesterday. And, okay, so requirements. I just want something that we can make notes inside our townsfolk. Requirement notes .md. All right. First thing we want to do is we are going to collect the concepts notes. These are just notes we made while talking through the requirements for the townsfolk. Generator. All right, so I think we're going to have, let's call them concepts. And then noun verb. That's going to tell us if our concept is likely to manifest as an object or as something that an object does or acts upon an object. Shared. Changes. Let's set up the markdown table. And this is just going to sort of help us organize our thoughts. And we have, did I do that right? Here we go. We have a character. A character could be a player character or a non-player character. And it is a noun. Shared? Yes. Is that character going to change over time? Yeah, a little bit. Like, are the material details of that character going to change over time as the application evolves? Yes and no. So let's, whoops, there we go. All right. And I want to see a preview of this just to see how it looks. Yeah. Actually, you know what I'm going to do is split down. It's not what I wanted to do. Let's put it in here. Whoops. Split down. Now we'll pull this editor down here. All right. Notes, I gotta put a space there. All right. We're going to need to store lists. And those lists, let's call those source data. No. We called those something else down below. Rule sets. Is a noun. Is it shared? Yes. Does it change? Once it's been established, once we've defined them and implemented them, I don't think a particular rule set is going to change all that much. So let's say no. And I've just had another thought on character. Within the scope of this use case, I'm going to change character to NPC. Within the scope of our townsfolk generator, an NPC, once it's defined, isn't very likely to change all that much. Not in any material way, anyway. Need a way to generate NPC's basic game stats. That sounds like that dice bag concept that we talked about yesterday. Is it shared? Oh yeah, we're going to use dice for everything. And then once the dice bag concept has been finished developing within the context of this application, it's probably not going to change all that much. Now, when we're doing this kind of thing in real life, I tend to do all of this stuff in my head very, very quickly. So it seems like this is taking a long time and I'm putting a lot of thought and I'm really kind of belaboring all of these points and all of that stuff. In reality, when I'm doing this exercise happens very, very quickly up here in my head. And I usually skip directly to Visual Studio and start sketching out objects and interfaces and all of those things. And then I move those around and I pop them into different projects and so on. And that happens very, very quickly. But I've got lots of practice doing this. And I think this is valuable for you because you get to see what a thought process might be that you could use when you're trying to take an idea from English language and turn it into computer person speak. And it's valuable for me because it reminds me of the actual process and talking it out. I strongly suspect I'm going to start to poke holes in my own process while we do this because I'm thinking about it, I'm slowing down, and I'm going to find ways that I can actually improve my process while I'm demonstrating it for you all. So this is going to be a win-win for everybody. Now, we should be able to supply basic information about a character to be generated. That is... Whoops. Let's call it seed. Info. it is a noun. Is it shared? No. Is it going to change often? Only by the variables that are provided and which of the variables that we're going to allow, which of those are provided. So this isn't volatile, this is variable. I want to move this up here so that it's next to the NPC, because that seed info, I'm going to change that from info to NPC seed. And I'm going to drop asterisk here. I don't want it to appear as a bullet point, so I have to get rid of that. What are you doing? There we go. Items marked with a asterisk aren't volatile, but they are variable. Let's make sure. All right, very good. So when we've generated an NPC, we should save that character's information. Whoops. Oh, what up? Save NPC. That's a verb. Are we going to be sharing the save NPC? No, the only thing that's ever going to save NPC data is our townsfolk generator. Is that going to change over time? Absolutely. At first, we're probably just going to dump it out to the file system. Later, we might want to put it in a database or somewhere else. We might want to send it to an API somewhere. I don't know. But the nature of saving that NPC is absolutely going to change over time. I want to get rid of... I've cheated. I'm sorry. I thought I had too far. Let's get rid of rule set. Whoops. Species list. It's a noun. It's going to share. We're going to use that all over the place. And once the species list has been designed, the shape of the species list isn't going to be very volatile over time. It might change from one version to the next, but within the lifetime of one release of this software, it's going to be stable. Same holds for background list, noun, shared, yes, changes, no. Profession list, same deal, shared, changes, no. I know why I wanted to get rid of the rule set and expand it into all of these things. What other things do we need to look for? Personality, how tough are they? Need to store some lists. Names, appearances, personalities, appearances. List, noun. Is it shared? The concept is shared. And the values are going to depend on the species usually. But is the shape, is the nature of an item in the appearances likely to change over time? And I'm going to say no. I want to pull that up, put it under species. What other lists do we have? Names, list, that's a noun. Is it shared? Yes. Does it change? No. Excuse me. And again, name is likely to descend, or not descend from, but the names that we pick for our NPCs are largely going to be informed by their species or their culture, because I haven't met very many elves named Gorg, but I've met a couple orcs named that. Well, I've never met any elves or orcs, except when I was in college. But yeah, you're not likely to meet a dwarf with the last name Leafwind, and you're not likely to meet an elf with the surname Orecrusher or anything like that. So let's make the names descend from species. And yes, we're oversimplifying and we're not being politically correct. It's a game. Species did not necessarily dictate culture. Yeah. But we need some constraints. And for the purposes of random generation, let's just hand wave all that stuff away. When we've generated, we should save that character's information to a file. Cool, we've got save NPC. Generate the basic information with an LLM. Okay, we're not gonna mess with that. Now, I did get rid of the dice bag. And how do we generate their basic game stats? We roll dice. And that is a verb. Is it shared? Absolutely. And does the nature of rolling dice change from one execution of the use case to the next? Absolutely. So we need to go down our list and see. I want to make these headers bold, just to make it a little easier to see them. Save. And we've got an NPC. That's a noun. Yes. No, it doesn't change. We want to look for the things that say yes or no. And instead of yes and no, I'm going to change yeses to no, a simple asterisk. No's are going to go blank. Because we want to be able to quickly skim down our list and see if we have anything that is volatile. That's volatile along both axes. Boop. Oh, and I gotta change that. Yes. Whoop. Save it. All right. So rolling dice. So the rule of thumb when we're doing this type of decomposition is if we have one dot in the row, we encapsulate it in its own entity. If we have two dots, we need to dig into that a little bit more. And if we have no dots, that means it's not volatile and therefore does not become a discrete class, service, component, whatever. It means it's something else. It's probably either just a hard-coded chunk of code, or it might be parameters to a function. It's not really an entity that we need to concern ourselves with at this level. And you can apply this type of thinking not just to the individual classes and functions of a system. You can take a look at a system from a much higher point of view and say, okay, so what aspects of our business are changing over time? What aspects of our business are reused from one area of the business to another, and do that same kind of breakdown. And that helps us define our services. And we do all of this at the use case level. So rolling dice. Let's take a look here. RollDice is both shared and volatile in its behavior from one execution to the next. That means we need to look at it more closely. And break that concept down further until we have smaller pieces that are volatile along exactly one of those axes. So what do we do when we roll dice? What changes when we roll dice in our game? The number of dice might be different for every situation. The kind of dice may also vary for each instance. And let's use that same language up here. Language matters. We may apply modifiers to the result of those dice in different circumstances. So, what if we thought of things like this? What if we made those things that can vary into parameters in our function? So that means what if we treat RollDice a single thing that we can do that means we roll dice. How many? What kind? Modifiers. We may also have situations where we roll more than the specified number of dice and ignore the lowest or highest when calculating the result. Advantage, disadvantage. We're going to need a way to represent that too, aren't we? All right, so what if we treat roll dice as a single thing that we can do? I mean, when we want to roll some dice, we just say roll 3d6, or roll 1d20, or roll for initiative, or make an attack roll. And all of those boil down to we pull a couple of dice out of our dice bag. Here's a d20. Here's another d20. We roll them around and we get our result. And I'm rolling an advantage. I'm going to use the highest number, and that's a 17. I hit the dragon. Hooray. We might also, when we're rolling characters, and I think I'm shy a d6 here. when we're rolling characters, our DM might be in a good mood that day and say, okay, well, when you're creating your character and you're rolling for your ability scores, roll 3d6, and if you get a 1, re-roll it once. So I got a 1. Right now I've got a 5, a 2, and a 1. I'm going to re-roll that 1. And I got a 5, 2, and 2. And that's probably going to go into wisdom because I'm rolling up a character who's a thief. And those are all the different kind of modifications that we could make to the way the dice are rolled. And those are the types of volatilities that we want to... Well, they're not even volatilities because we're rolling a number of dice and we're rolling a number of the same kind of dice, usually. And then we're either adding or subtracting some set value, or we're adding another die to the roll and dropping the lowest or highest if we're rolling for advantage or disadvantage. And those are all just parameters of this function. So how do we express this? Well, when we break it down like that, we've got both modifiers as a result modifier and roll modifier. So, and let's just do this way. And I don't know if this is going to result in me having a comment or what, but how many is the number of dice to roll? What kind is the type of dice we'll use? Result modifiers will add or subtract a set value, a provided value from the result once it's been calculated. Roll modifier is a special condition. Will change the number of dice that are rolled and how they are totaled. That seems like a pretty complex idea to me. So I think I like to tackle the hardest parts first, or the most complex. And this all feels pretty complex to me. And because we're going to be extending this or adding capabilities or what have you, I feel like this belongs in its own concept within the context of our software. RollDice. Let's wrap all of these concepts up into a single section of our code when we get to it. We'll call that section a dice engine. That's the label we'll use for the box we'll put all the dice stuff into. We'll call the thing that owns the function of rolling the dice a dice bag. All right. I'm going to save this. And I need to Google something really quickly. Let's pop a new window. Where's our new window? Here we go. Strike through text in Markdown. Mention to tilde before and after the text. Cool. Over here we go. I'm going to grab this. Oh, goodness. That's not what I wanted to happen. Hey. And let's just take that out altogether. Now, we have every time we call RollDice, it's going to look approximately the same. We're going to be passing some or all of those parameters into, oh, I'm trying to edit the actual preview. I overslept today and I am only a little bit into my second coffee. So roll modifier, when we call dicebag.rollDice, we'll always be passing in how many and what kind. We might pass in a modifier to the roll itself. We might pass in some modifier that we want to apply to the sum of the dice that got rolled before it's sent back, whatever. But now that we've done this thought work, we've come to a place where RollDice is going to be approximately the same every time we call it. And the way we call it isn't going to change whether we're generating a townsfolk, whether we're tracking initiative, whether we are rolling for damage because the wizard cast a fireball in the potion shop. It doesn't matter. It's gonna be the same every time. And we've just made this into a component that can be shared. And if we need to change the internal behavior, we can do that without changing every other part of the code that uses it. And that's why we focus so much on, does it change? How can we make the external part of the code, that the rest of our components interact with, we have to work really, really hard to make sure that that external part, the API, is stable over time. Because every time we alter an API, we then have to alter every piece of code that uses that API. And that's how we end up falling down rabbit holes and taking a change that should take a day and have it end up being a week because it's cascaded throughout our very large legacy application. If we spend a little bit of time, like we've been doing, on planning out what are the pieces of our code and how do they interact, and how can we make sure that the way they interact is stable, we save ourselves those nightmare scenarios 6, 8, 10 months from now when somebody asks us to make a change, and all we have to do is make that change to that one little piece instead of changing that one little piece and then having to go change 36 other places in the code that use it. And that's why we use volatility-based decomposition. I think we've got a really great candidate to start writing some code. Now, we've got about 12 minutes left this morning. Added a file with notes about the townsfolk generator. And I almost did a very, very bad thing. Almost. I almost deviated from the plan. I almost dove into the code. Almost gave into that temptation. Instead, because I'm really eager to get into some code too, I'm going to come back to our stuff. And I'm going to flip over to our other branch and make sure that our requirement notes are here. Very good. These are just notes we made while talking through the requirements for the townfolk generator. Items marked with a star aren't volatile, but they are variable. And we're good. I really should have used a different glyph for those. Because I'm using the asterisk as a thing to denote things that aren't variables. So I'm going to change these into yeses, but I'm not going to put anything in the no columns. I also want to pop that up in here. We now have the dice bag. It's a noun. No, it's a service. It's shared. It isn't materially going to change over time. Did I bollocks anything up here? I did not. Okay. There's that. And excuse me, dice bag service. I feel like I just lost something. I lost a row. Save NPC. Gosh. Come on, Rob. Save NPC. That's a verb. Excuse me. No, it doesn't change, or it's not going to be shared. Yes, it will change over time. NPC seed star NPC seed is a set of basic attributes that may or may not be used to predefine certain aspects of a townsperson. All right. I was going to say let's dive into the code and build our dice bag service, but we have another step ahead of us, and I almost cheated us. I almost deviated from the plan, and I've done that before on my website project, and I lived to regret it. We've also completely ignored any of our technical requirements because I'm kind of a dope like that. Let's go back to our requirement notes and review those technical requirements. Come into the townsfolk generator where the technical requirements live. Okay. The components we create for this application should be as reusable as is practical. That's what our discussion about, does it change over time? Is it shared? That discussion is working towards making sure technical requirement number 1 is met. We do not want reliance on external resources like databases, AI models, or anything like that. The application should run locally on the end user's own hardware. We're not even there yet. As the application grows, we may need to move some capabilities into their own component areas. This is also being fed by our discussion about what changes. This line here, don't build this as a microservices system now. That's a guideline for when we start designing the architecture. And when we get into designing the architecture, and I think that is actually the next step in our process, we're going to see that the way we design this system and the way we distribute the responsibilities for fulfilling those requirements across the components that we design, we're going to see that as long as we stick to the architecture that we draw out this afternoon, pulling a piece out and putting it into a discrete service later, if we need to, it's going to become fairly trivial. It becomes an implementation decision at deployment time if we do it right. And I'm going to talk us through doing it right. There are lots of ways to do things right. Well, no, that's not true. There are a few ways to design a software system correctly, and there's a lot of ways to mess it up. I'm going to try to keep us inside that list of few ways. There is one way, this volatility-based decomposition. IDesign, the company that I learned architecture from, they call it the method. That is the design system that I am most comfortable with. I'm most experienced with it, and I've had the most success with it. Anytime I've used their techniques in a project, it hasn't completely failed. And to me, that's a win. Most of the times I've used their techniques, it's been a win. And when you've got, I think the statistic I saw recently was 3/4 of all software projects collapse under their own weight and fail. Using a system that reduces that failure rate to below 50%, I'll take it. I'll absolutely take it. So back to this. This is going to be a local application with a simple user interface. I'm going to be honest, we're going to do a console app for now. Later, if we want to add sort of a graphical user interface, I might do some exploration with Blazor or maybe even Maui if I'm feeling spicy. Who knows? But to start, while we're building the system and its core capabilities, a console app is going to be plenty, just for testing and so on. We won't have the cognitive overhead of me trying to learn a UI technology in front of you all, because that's what's going to have to happen for that. But console app, and honestly, with this architecture we're going to use, the front end technology doesn't matter. We can slap whatever kind of front end we want on there. We're going to be building in C# using the dotNet 8 framework. Great. There are some cool things in dotNet 9, but I've gotten in the habit of only using the even-numbered framework releases, kind of like Star Trek movies. The odd-number framework releases, the only reason I don't switch to those is because of the support life cycle on the odd-numbered ones. Those are standard term support, which usually is about a year for actual updates, and then another year for like security patches and so on. The LTS, long-term support releases, those are even numbered, and they've got a longer lifespan. I'm just in the habit of using the even-numbered ones. We'll add automatable tests as appropriate as we implement our components. So that's going to be a session or two, maybe even later this week. And if LLM usage is built, let's target a small language model that can be run on my hardware. And I'm running a MacBook M2 with 8 gigabytes of RAM, and that 8 gigs is shared between all of the cores, the CPU, GPU, and NPU. Back during Microsoft Build, I experimented with installing Phi 3 Mini using Jan AI as the AI host application, and I was actually able to chat with the small language model right on my local desktop. I shut off my Wi-Fi, I pulled my Ethernet, and it kept working. It used a lot of RAM, and the keyboard got a little hot to the touch, but that's probably going to be our best bet. So if we get to LLM usage, we'll probably use that, because I don't want to pay for Azure OpenAI service because I am unemployed and don't want to spend money that I don't have to. This afternoon, we are going to start architecting our solution. Let's take a quick look at GitHub before we sign out. I want to go to the projects and our project tracker. Analyze the requirements for the requested MVP feature. Add ratings to each on the 2 kinds of volatility we want to address. And we are done with this tool. Oh, come on. Here we go. Analyze the requirements. Blah, 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 blah. Good. In progress. Done. Yes, I know I could have dragged it. But, and then user requirement analysis to create our first draft static design. That's this afternoon. I will see you all at 1 o'clock Eastern time, same place, and we're going to start sketching. Until then, go get yourself something to eat, drink some water, maybe go outside, see some green things, and be good to yourselves.